Problem 40. Prove that the limit as x goes to 3 of x squared equals 9. To prove, we have to use the definition of limit, and recall that that says that the limit as x goes to c of f of x equals L means that given any positive number epsilon, we can find a positive number delta so that if x is within delta of c, then f of x is within epsilon of L. So in other words, what we need on this is f of x minus L less than epsilon. So we need x squared, that's our f of x, minus our limit to be less than epsilon. We can factor this up as absolute value x plus 3 times absolute value x minus 3 less than epsilon. And now we need to say something about x plus 3. If we look at our definition, this says x minus c is less than delta. So the c in this case is 3. So this says x minus 3 is less than delta. So this part is going to be the one that's less than delta. But we need to focus on the x plus 3 over here. So what I'm going to do is I'm going to make the requirement that that the delta that we choose will be less than or equal to 1. And we're going to make this more formal when we go and do the actual proof. But for now, let's just insist that delta be small enough, that delta be smaller than 1. If that's the case, then x minus 3 is less than delta, which means that x minus 3 in absolute value is less than 1. So x minus 3 is between 1 and negative 1. And now I want to say something about x plus 3, about this other factor. So we can add 6 to all three sides of the equation, and this gives us 5 is less than x plus 3 is less than 7. So we know now something about x plus 3. So let's now go and look at the actual proof. So the proof, we'll start out with the definition. Given our positive number epsilon, we're going to let delta equal, now we're requiring that delta be less than 1, so we're going to say that this is going to be the minimum of 1, and this other thing that we're going to compute in just a moment. So let's figure out what that other piece is so we can proceed in the proof. So we know from here that x minus 3 needs to be less than epsilon over absolute value x plus 3. And this needs to be less than delta. So we need delta to be less than or equal to epsilon over x plus 3 in absolute value. But now x plus 3, the worst case scenario, if we want to make this as small as possible, we'll choose the denominator to be as large as possible. And the biggest that we can make the denominator is 7. So we'll choose delta to be epsilon over 7. So that's going to be the other piece in the proof. So delta will be the minimum of 1 and epsilon over 7. So this lets us say two things. First, this says that x minus 3, according to our definition, x minus c is less than delta. So x minus 3 is less than delta. And since delta is the smaller of these two, we can say x minus 3 is less than 1, and x minus 3 is less than epsilon over 7. Now I want to convert this statement about the 1 back into something about x plus 3. So this says that x minus 3 is between 1 and negative 1. Adding 6 to both sides says that x plus 3 is between 5 and 7. So in particular, everything is positive here, so we can take the absolute values and nothing changes. So the absolute value of x plus 3 is between 5 and 7. So that means if I take the function x squared minus 9, this is the same as x plus 3 times x minus 3. X plus 3 is less than 7. X minus 3 is less than epsilon over 7. So this tells us that x squared minus 9 is less than, multiplying these together, the 7's cancel. We get that this is less than epsilon. This x squared was our function, f of x. This 9 was our limit, L, less than epsilon. And this is what we were trying to prove.